Hi friends, this is Nagajyoti working as an assistant professor in Department of ECA in St. Peter's Engineering College and dealing with a course of linear IC applications. In linear IC applications, now in this session we are dealing with Unit 4 of PLL, that is a topic of phase locked loop. So here a phase locked loop is basically used in order to demodulate a frequency modulation. So PLL is used in the applications of frequency modulation in order to demodulate the FM wave as well as in order to generate the frequency shift keying techniques in case of a communications in order to detect the FM wave as well as in order to generate an FSK wave will be using a phase locked loop, and this phase locked loop will be available in a single package with numbers maybe 560 or 561, 62, 64 or 65, and this is a block schematic of a PLL. So in case of a PLL, it basically consists of three different blocks. The first one is phase detector, second is low pass filter, and the third one is voltage control oscillator. Now let us see the functioning of each block in detail. So here the input signal is applied to a phase detector. So here the name itself indicates it is used in order to compare the input signal frequency with the feedback frequency. So the output voltage of the phase detector will be DC voltage, and therefore it is also called as error voltage amplifier. This output of phase detector is then applied to a low pass filter which removes the high frequency noises and produces the DC level, and this DC level is given to a voltage controlled oscillator. So here the function of a filter is to help, depending upon the DC value which we are getting, the voltage of a VCO is directly proportional to the input, means whether it may increase the frequency or decrease the frequency depending upon the DC level of a low pass filter. So a phase detector performs two functions. One is it acts as a multiplier, so it produces two frequency components at its outputs. One is sum of the frequencies and the other one is difference of the frequencies. These, as it consists of two frequency components, some of the frequencies will be having the highest frequency component, so that will be rejected, and the difference of these frequency components will be passed through a low pass filter which will give an output of DC level. So the low pass filter will amplifies the low frequency signals, and this VCO output will have certain frequency. So if we are not applying any input to the VCO, even though it gives a certain DC level, and this DC level is again compared with that of the input. This process is continued until the phase detector output is equivalent to 0. So this phase detector may be either digital phase detector or analog phase detector. So if we want to use a digital phase detector, we need to use a simple XOR gate In case of an XOR gate, when both the inputs are different, output is equivalent to 1. So if the input frequency and the feedback frequency is not matching, the output is 1. If both are same, the output is equivalent to 0. And the phase locked loop can be operated in three different modes. One is free running mode, second is capture mode, third one is lock mode. So if we are not applying any input signal, but if we are getting some frequency without application of an input, such a frequency is called as free running frequency. And the capture mode or a capture range is when we are applying some input signal. Because of this applied input signal, the output signal of VCO will start changing. So at this stage, PLL is said to be capture mode. That is, in case of a free running mode, without application of an input signal, there will be a frequency. But whereas in case of a capture mode, by application of an input signal, the output of a VCO is continuously changing. This continuous change of mode of operation is called as capture mode. And the last mode is lock mode, in which the output signal frequency of VCO will change continuously until which it should be is equivalent to input. So when input signal is equivalent to VCO signal frequency, then only the PLL is said to be in lock range. And we need to remember here three formulas. So the formula for the free running mode is 1.4 divided by R1 C1, and for the capture mode and lock mode, the output depends upon how much amount of input we are applying. So by comparison of input with the feedback path only, we can able to calculate the capture mode as well as lock mode. Thank you.